The question is, can you find a vector u in R2 such that u dot u is equal to 2 and u dot 1, 1 is equal to 0? Are there any other such vectors? Well, I think it might be easier if I knew the components of the vector. So let u be equal to x, y. Now I can do u dot u and u dot 1, 1. So then u dot u is equal to xy dot xy. So that would be equal to x times x, which is x squared, plus y times y, which is y squared. Now u dot u is supposed to be 2, so therefore x squared plus y squared equals 2. Alright, let's do u dot 1, 1 now. U dot 1, 1 is equal to xy dot 1, 1, which would be x times 1, which is x, plus y times 1, which is y, and that's supposed to be equal to 0, so therefore x plus y is equal to 0. So we could rearrange that to get y is equal to minus x. So y is equal to minus x. Now I know what y is, I can sub it back into the equation I got up there. So x squared plus minus x squared, because y is minus x, is equal to 2. So, well, minus x squared is the same as x squared, so 2x squared is equal to 2. So x squared is equal to 1, which means that x is equal to plus or minus 1. Alright, now I can sub this x back into my other equation. It will tell me what y is. So let's do them separately. If x is equal to 1, then y would be minus 1, so that would be minus 1. So then y is equal to minus 1. So u would be equal to x, which is 1, y, which is minus 1. If x is equal to minus 1, then y would be equal to minus minus 1, which would be 1. So u would be equal to x, which is minus 1, y, which is 1. Now, the question said, are there any other vectors? And I don't think there are, because I've covered all the possibilities for plus and minus 1. But there's probably a geometrical reason why there are only 2 of them, so maybe I should draw a picture of it. But let me just write that down. There are exactly 2 such vectors. And I know that's true because of the way that I solved it told me that there were only 2 possibilities for x, so therefore there are only 2 possibilities for u. But as I said just before, maybe I should draw a picture of it to see why there are exactly 2, just to convince myself that my answer is right. So here's my y-axis, and here's my x-axis. Now I've got the vector 1, 1, and that's the point 1, 1 there. So the vector 1, 1 is here. And my u is supposed to be perpendicular to that, because u dot 1, 1 is 0, which means that it's perpendicular to 1, 1. So u must lie along this line. And u has to have u dot u equals 2, and the length of u is actually the square root of u dot u, so the length of u is root 2. Now these 2 vectors here have root 2, and they both lie along u, so both lie along that line that's perpendicular to 1, 1, so there are exactly 2, just as we thought.